Okay, so in this we're going to focus on the basics, very, very basics of graphing tangent, cotangent, cosecant, and secant. We are not trying to become experts in these by any means. That is not the point of this class. All right, so in order to understand, we're going to focus on tangent because that's what we have here. How does tangent relate to the values on the unit circle? Great, very good. It's y over x, right? So now if you notice here, I've kind of laid out one time around the circle, but I've only included values that tangent, or the inputs that tangent has, well, I'm going to say nice value at, which is 1, 0, or -1. Those are what I'm calling the nice values. Sorry, that looked kind of sloppy. And then also tangent can be undefined. So let's go ahead and plot those values. Well, what is the tangent of 0? The tangent of 0 is 0. What's the tangent of pi fourths? The tangent of pi fourths is 1. What's the tangent of pi halves? Good question. It doesn't exist because it's undefined, because that would be where we're dividing by 0. What happens when we graph undefined? We get a vertical asymptote. What is the tangent of 3 pi fourths? That is going to be -1. The tangent of pi is 0. The tangent of 5 pi fourths is back up at 1. And the tangent of 3 pi halves, again, that gives us a vertical asymptote. Continuing on, tangent of 7 pi fourths, back down at -1. Tangent of 2 pi, back at 0. So what does this actually look like if I try to connect these dots that I've made? Well, it looks kind of like this. Where, again, I know that these graphs continue on, remember? So I know that this is going to continue on here. There's going to be another asymptote, and this side is also going to continue on as well. So that's what our tangent function kind of looks like. Now let's answer a couple of questions. Well, what does a period represent, right? A period is the distance of one complete cycle. So look back at this graph. Where do we see one complete cycle? Very good. In between the asymptotes, right? So one complete cycle is here. And so if I know that that is from pi halves, that's a bad notation, to, I'm just going to write the word, to 3 pi halves, then I can tell that the period of a tangent function is pi, right? I don't like the equal sign there either. So that's going to be the period of a basic tangent function. Now, let's talk about some other things with tangent. So what do we say, or what have we said, what does amplitude represent? Very good. It's half the distance of the range. Now, a key word there is distance. So if I look back at this tangent graph, well, I'm drawing these arrows, right, which are indicating that the graph is going up and it's going down forever. So what would the range be? Well, the range would be -infinity to infinity. What is the distance of -infinity to infinity? That's infinity. What is half of infinity? Still infinity. So we can't designate an amplitude, so the amplitude for tangent is none. What is the period? The period is pi. And we just talked about that. What is the domain? So the domain, we're going to have a different notation that maybe you've seen this before, maybe you haven't. But if we go back to this picture, notice that we have asymptotes, right? And as I mentioned, those asymptotes are going to continue on. So as the graph continues on, we're going to keep having more and more asymptotes. So the domain is going to be all real numbers except for all of the asymptotes. But there's an infinite amount of asymptotes. So how do we represent that? So I'm going to use this fancy symbol. That means all real numbers. I'm going to say all real numbers except for x does not equal, and then I'm going to pick one of the asymptotes. So there was an asymptote at pi halves, and then I'm going to say plus, so plus the distance between asymptotes, which was coincidentally the period for tangent, and then n, where n is representing any integer. Now, the other thing I'm going to do really quickly is actually draw you the basic tangent function. So I showed in the previous graph how we came up with tangent by just plotting some points from the unit circle, similar to how we came up with sine and cosine graphs. But the basic tangent graph, so what you want to, again, kind of memorize for one image of tangent, we're still going to have our 5 marks, but tangent is unique compared to all of the other trig functions in that the basic graph does not start at an x-coordinate of 0. The basic graph starts at negative pi halves. So when we graph one period of tangent, we're going to have an asymptote to start and an asymptote to finish. And the shape of the graph is going to look like this, where these values are at 1 and at negative 1. So this right here, this image, this is what you want to think about when you think about the graph of a tangent function. This is one period of a tangent function, so we still have 5 marks for one period. However, 2 of those marks, the beginning and the end, aren't actually points on the graph, they're asymptotes. That's tangent. Any questions? All right, moving on. Cotangent. So instead of using the unit circle for this, I'm gonna actually do both. I'm gonna use the unit circle, and I'm also gonna think about cotangent in terms of cosine and sine. So here in the light green and in the light red dashed lines, the green is the sine function, the red is the cosine function. We know that cotangent in terms of the coordinates on the unit circle, so that's confusing if I write that. In terms of the coordinates on the unit circle is x over y, right? Because it is adjacent over hypotenuse. And in terms of sine and cosine, it's cosine of theta over sine of theta. So what does the actual cotangent graph look like then? Well, anywhere that the sine function is 0, cotangent is going to have a vertical asymptote because it will be undefined. So I know that these are going to be asymptotes. Anywhere that the cosine function is 0, so wherever the red curve is 0, the cotangent function is also going to be 0. So I'm going to have a point here, a point here, a point here, and a point here. Anywhere that they are the same, so that the sine and cosine are the exact same value, I'm dividing two things that are the same, so that's going to give me a value of 1. Anywhere that they are the same but opposite, so one is positive and one is negative, that's going to give me a value of negative 1. So my graph, or many periods of my graph, is going to look similar to the tangent, but going in a different direction. And I have a different starting location. So for the basic cotangent graph, this is the picture you want to memorize with those values. Again, it's 5 marks, so starting with an asymptote, I have a point, a point, there's the point, and then another asymptote. So that is one period of the cotangent function. So we're going to go through this a little bit quickly. The range, negative infinity to infinity again. The period is pi again. The amplitude, again, is none because of the range. And the domain is similar to tangent, not exactly the same. It's going to be all real numbers, except for x does not equal, pick an asymptote, I'm going to say 0, plus the distance between asymptotes times n. Now, because this is a 0 here, you don't actually have to write it. You could just say x does not equal pi n. Similar to what we did for the tangent. Questions on that? All right, moving on. Let's do cosecant. So cosecant we're going to get from the sine function because I know it is a reciprocal of the sine function. So cosecant is 1 over the sine of x. So anywhere that sine of x is at 0, cosecant is going to have an asymptote. Anywhere that the sine has a value of 1, cosecant will also have a value of 1. Anywhere sine has a value of -1, cosecant will also have a value of -1. Wherever sine has a value of 1/2, cosecant will have a value of 2. Wherever sine has a value of -1/2, cosecant will have a value of -2. So the cosecant image is like this. And I want to point out these kind of look like parabolas, but they're not because of the asymptotes. So parabolas would go to the left and right forever. These are bounded by the asymptotes, but they kind of look like that shape. So anyway, what is one actual period of cosine though? Remember, a period is a complete cycle. So just so we don't want to get confused with tangent and cotangent where the periods were a complete cycle, but they were also bounded by the asymptotes. Here the asymptotes don't bound a period. So one period of cosecant looks just like that. That is one period. So that because that is a complete cycle. Let's talk about these values. So the range of cosecant is going to be -∞ to -1, including the -1, and then 1 to infinity. So therefore the amplitude is none. The period is 2 pi, and the domain is going to be all real numbers, except for pick an asymptote. So I'm going to say, whoops, x does not equal, again, I'm just going to choose 0, plus the distance between asymptotes is pi, and then times n. So notice here that the distance between asymptotes and the period are not the same thing. Again, all you need to get from this for this particular class is just kind of have a general idea of how could I graph cosecant, and it's based on the sine function, and then what does that image actually look like. Now we're going to do secant. Same sort of idea. It's going to end up looking very similar. So here we know that secant is 1 over the cosine of x. So anywhere cosine is 0, secant will have an asymptote. Anywhere the cosine function is 1, the secant function will be 1. Anywhere it's -1, the secant function will be -1. Anywhere the cosine function is 1/2, the secant function will be 2. Anywhere the cosine function is -1/2, the secant function will be -2. So now if I draw these shapes, my graph is going to look like this. Oops, let's do it this way. So we're probably thinking, so where is one period, right? And because I know that's the distance of one cycle, I see a couple of things that might be a cycle, but this is going to be based off of what is the period of cosine, which is going to be 2 pi. So that's going to be our cycle. Now I want to emphasize, just like with sine and cosine, if you graph them on forever in both directions, they actually can be interchangeable. It can be sine or cosine. Same with secant and cosecant. Okay, so, but the image of one period, sorry, I'm getting distracted. The image of one period does look different. So the range is the same, -∞ to -1, 1 to infinity. Therefore, our amplitude is none. The period we just talked about, that is 2 pi. The domain is going to be all real numbers. X does not equal, pick an asymptote, plus the distance between asymptotes, n. So that is the secant function. Last thing then, what are our strategies for graphing cosecant and secant? Graph sine or cosine first. So treat it as if it was a sine or a cosine function, respectively. plot all of the exact same points, but then draw the asymptotes in the shape of the secant or cosecant instead.